This is Solve It for Kids.
Hello, my amazing and curious friends. My name is Jennifer, the Dean of all things STEM and STEAM, and this is Solve It for Kids, a podcast that gives kids and families a peek inside the real world of scientists, engineers, and experts as they solve problems in their jobs using creativity, cooperation, and critical thinking. And now please welcome to the show my podcast partner, Galactic Space Geek, Jeff Gagne.
Hello, Jennifer, and hello, listeners. We need to get right to today's episode because we are talking about science that is literally happening right now.
Exactly. Oh my gosh, this is going to be so amazing. What problem are we solving today?
Why do science at sea?
Ooh, why do science at sea? Oh, I think I know where you're going with this, Jeff. Who is our guest today?
Our guest today is the fantastic science communicator, Erin Winnick Anthony. She is currently serving as the onboard outreach officer aboard the Joy D's Resolution ship.
Welcome to the show, Erin.
Thank you so much. Excited to be back and talking about something completely different this time.
Exactly. So why don't we just jump right in? Can you tell our listeners exactly what you're doing right now?
Yeah, so I'm currently talking to you from the middle of the ocean, which is kind of crazy. So I am on a ship called the Joy D's Resolution. That's a scientific ship. I have been on it now for 6 weeks, and we are doing geology research. We're going to be out here for 2 whole months straight. Yes, that means we're not going back during any of that time to shore. And it's all for science. We're taking cores of rock of the ocean floor, going down over a mile underneath the seafloor, getting rock from millions of years ago to solve some very specific problems that I'm sure we will get into more. But yeah, at its core, we are taking a bunch of rock from underneath the earth.
Wow.
Okay, can you explain how, from a boat floating, you are getting cores from the bottom of the ocean?
Yes.
Yeah. So we have a large drill on board, a coring drill, that sends down a pipe basically from our floating platform down to directly under wherever we are. So sometimes that's going down 500 meters, sometimes it's going down thousands of meters down through all of that water.
Wow.
And at the end of this pipe is something that's able to carve out rock from down, deep. And then kind of like, honestly, like an elevator shaft, we are able to pull up those cores of rock through that tube over and over again to be able to get down as far as we want to get some of those Earth secrets that we're looking at.
Wow. So when you do that, are you using some sort of like vacuum to pull up the actual core? Because I'm kind of wondering, how does that actually work, right?
Yeah, kind of crazy, but it is like a pulley system, like literally like an elevator that sends these tubes up and down. So we have one tube on the outside that stays down the whole time, and then interior ones there's one that's able to go down and up at a time. So they can't pass each other, but it goes down, and then we're able to pull it all the way right back up.
Okay, that makes sense.
Got it.
Yeah.
Okay, so in these cores, is it dirt? Is it packed dirt? Is it solid rock?
Good question. So the Joy D's has done a bunch of expeditions, and the answer would be different for everyone. But for ours, first of all, we're getting a lot of mud, which is gray mud.
Okay.
I know might not sound exciting, but our scientists on board are very excited about gray mud because it has a lot of other things in it, like tiny fossils and the very specific type of formations that allow us to learn about how the ocean flowed and currents from a long time ago. We've gotten some sandstone, so we have hit some harder rock and things like that as well. And then within that, there's tiny amounts of other different types of minerals and things like that. But the tubes largely look very gray, variations on gray with some like a little bit leaning more green and things like that. And our sedimentologists, I'm sure, would be able to tell you the 15 different shades of gray that we have seen and what they all mean. But yeah, largely to all of us would look like mud and harder mud.
Yes.
All right.
So now tell us kind of where you guys are going, because I know you started at one place kind of in the North Atlantic, and now you're kind of going around. Are you heading into the Mediterranean? Is that where you're headed?
Yeah, so we started in Amsterdam. That was our starting point. And then we had like a 5-day transit. So 5 days of sailing to get to our first site. And we've been largely off the coast of Portugal and Spain so far. And then in a few days, we're all very excited because we're going to be going through the Strait of Gibraltar. And this is a very narrow point between Europe and Africa. And so we're hoping that it's during daytime and we can see both continents at the same time.
Oh, that would be cool.
We'll be going in. So yeah, the end of our expedition, the last like couple of weeks, will all be in the Mediterranean.
Okay. That sounds really cool, by the way. I'm really hoping it's daytime for you as well. Seeing 2 continents, that sounds awesome. I was reading up a little bit about your mission, and these cores are being taken to study the interchange of water, the ocean water, between the Atlantic and the Mediterranean. Why is it important to study that?
Yeah, so right now we are looking back millions of years into the exchange of water between the Mediterranean and the Atlantic, because we're looking at a time when they actually got cut off from each other. So the Mediterranean got completely cut off from the Atlantic due to movement of the tectonic plates.
Oh, wow.
When this happened, the Mediterranean largely dried up and left behind a bunch of salt. So, if you've ever been in the ocean, you've tasted that salt and that salt water. Well, when the water goes away, the salt stays behind. And we had about a 1,500 meter layer of salt that was like just left there at the bottom. And this had huge impacts on the Earth's oceans, circulations, chemistry, and even potentially contributed to a period of global cooling. So this had a major impact. And by studying what this extreme period, we can learn more about how our Earth's oceans respond to really extreme periods and changes. So it can help us refine like our climate models and understand how our Earth responds to these sort of things. So we're largely looking back at this really extreme time of this exchange between the Mediterranean and the Atlantic.
Wow, 1,500 meters. Had no idea you'd find a salt layer that thick.
Yeah, huge.
I mean, that's incredible. So can you tell us a little bit about some of the science that you're doing on board? Because once you get the cores up, kind of like, do you do the science there, or do you take them on shore, or how does that work?
Yeah, so we do as much science as we can here. And there's some that's really important that we do on the ship, partially because we want to figure out how deep we have gone in Earth's history. So there's a number of scientists who are trying to figure out how old this rock is, because we really want to get to this period of 5 to 8 million years ago. And we don't know how old it is on the ship. We won't know if we've drilled deep enough. So we're studying tiny, tiny fossils of creatures that lived all this time ago. Since we know when they lived, we can help date these rocks. We're also looking at a number of other properties. So we have sedimentologists who are basically looking in these tubes. They're looking at the colors, the different types of minerals, and they're able to get some just like surface level, no pun intended, information about these rocks and cores so they know kind of what we're pulling up. And then we're also looking at some other basic properties that just allow us to have a basic understanding of, okay, what are we actually getting here? Are there other questions that we need to ask? Other data that we could be taking that would help us know if there's some other place that we should explore, things that are basically helping us with our like day-to-day decisions. But then this is going to inform science for more than a decade, basically.
Wow.
So all of these are going to go to a sampling party in 6 months where all these scientists get together and are able to pull the samples that they want from these cores and take them back to their home laboratories and study them and study a bunch of other things. And then they'll also go to what I would basically call a core library. It's the core repository. And scientists are going to be able to request studying these for years. So we've been taking cores for more than 50 years. I could go and ask to look at cores from 50 years ago because they're all still stored in these libraries today. So they're going to become a member of the Bremen, Germany core repository after the expedition.
Wow.
And Jonathan is here too now. Jonathan's one of our scientists for physical properties, and he's going to come join us and answer some questions as well.
Fantastic. Well, Jonathan, welcome to the show. We are excited to have you. Hopefully people will have watched the video, but just in case they didn't, could you explain again who you are and what you're doing on the ship for the research?
So my name is Jonathan Stein. I'm a postdoc at the University of Minnesota, and I work in what's called the Physical Properties Lab, which we're the first people to look at the core, and we measure the various important characteristics that are really good for correlation, and those are density, magnetics, how active it is, and how well sound can travel. And so what I do is I take the core, I put it through this core logger, this machine, and it measures all those properties for lots and lots of core, making really long records that I then can analyze for correlation and figuring out changes in climate, et cetera. And so that's I guess quick elevator pitch of
that works.
At least here on the ship.
Okay. No pun intended, because Aaron was just explaining how it's like an elevator that you get the cores back onto the ship.
Oh, yeah.
So while you are taking all of this information about the physical properties, are you finding any surprises in the cores that you're taking?
So much. Which ones are most important? Which ones most relevant for your audience? That's one of the coolest things I found was that generally you would think that these properties would all kind of associate with each other. So you would expect something more radioactive to also be more magnetic. And that's because both the radioactivity and the magnetics are for the most part carried by these fine clay particles. So you associate increase one being the other. But one cool thing that I saw here that I didn't expect was that sometimes you actually get the reverse, where a high in one is actually a low in the other. And that's actually one thing I'm considering doing research on once we're off the ship. Yeah.
Cool. And we were just talking about how there's a lot of research that's done off the ship too. It's all done right here.
I am super excited, about that. Get a chance to look at all this stuff,
So I'm just curious, when you pull the cords here, I know you want to do some immediate science, right? And that's just kind of to establish it. Maybe you label all of these, I'm assuming, so you know where you took these and all this kind of stuff. Do you do that with these cores?
Oh, yes. We have a very detailed sampling system, sampling protocol that we have to follow. Actually, the guy who sits in this office, Carl, he's the curator of all the samples. And it is it is a very important job because even though we only have less than 100 scientists, lost track. It must be hundreds, maybe even thousands of samples so far. But it's tracked all of them, where it's taken from, or what when it was taken, what test was done on it. And that's just what's done on the ship. There's going to be even more. Once when the core gets put away, we put in even another request about what we want immediately sent to us. And then we have another sample party in Bremen later this year. Yeah.
Lots of samples.
Yes. But that's a good thing. So this way, for people in the future, if they want to correlate, where were these samples taken from? Maybe this fossil thing occurred with this interesting magnetic thing that I found, and they can maybe, correlate that stuff and taken, look for potential problems, or really well organized. I was actually
and I'm really assumed used to be by notebooks probably a long time ago. Now you use computers to help you organize all of this.
Yes,
lots of digital records for sure.
So with this specific mission 401 and the water flow between the Atlantic and the Mediterranean, was there a target goal for taking these core samples? Was there something specific that scientists were looking to find?
Yeah, so actually, thank you for asking that. I prepared for a question like this. I wrote it down in my notebook.
I'm here to help.
On a grand scheme, there's many things we want to look at, but I think probably one of the biggest thing we're all really looking at here is climate. And one of the things you can think about it, imagine looking at tree rings. Cut into a tree and you could see a thicker ring that was probably a wetter year, and a thinner ring was probably a drier year. And sometimes they can vary with the seasons. And you can think of these sediment cores kind of tree rings on a million year scale. So that's what I'm looking at when I'm seeing these magnetic highs, magnetic lows. It's kind of the thick tree ring, the thin tree ring. So I can see kind of wetter year, drier years. And one of the things that's really cool is, so I don't know if you guys familiar with that same concept of looking at ice cores in in the North Pole.
Yes.
Well, actually, this site that we just finished drilling, that was actually one of the first sites that one of the guys actually worked on, that Shackleton. He correlated the properties of the sediment here directly to changes in climate in the Northern Hemisphere. So that's one of the things that we're continuing to look at to see how deep that record goes. That's just one of the many things we're looking at here.
Sure.
Well, And that's the thing too. So as you go around and you move around where you guys are you seeing different things? Like, are there different deposits in different places that you guys have found? Or are you seeing like the same kinds of rocks at the same depth? Or does this kind of like, what does that tell you what you're looking at?
Yeah, they definitely do change. It's actually kind of funny, at least the first couple of days. You'd be like, oh, what kind of different rocks do you see? The sedimentologists are like, oh, gray rock and a slightly less gray rock. And then, but you can see like between this site and then the site before this, 1610, which was a little closer to Spain. Mm-hmm. Yeah, it was much sandier and the deposits were like much thicker. Like we expected to hit like the 6 million year target. I mean, I forget the exact depth, but let's just say like 500 meters, and we didn't hit it to like 900 because it was just so much thicker than we stand here too. And it was actually in that site that I saw that kind of like that weird trend where the magnetics and the natural gamma and density kind of like inverted with each other. So that was really cool to see.
I'll add to one thing real quick too. One of the currents we're able to kind of follow. So one of the things we're looking at is like the path of like the water flow and stuff.
Right.
And we're drilling it point along that current.
Yes.
So we can kind of follow that along in these cores as well.
Exactly. And I mean, like, I'm hoping that the sand has something to do with the current, but like, I want to, for the people, yes, wait for the science. Yes. Thank you.
Okay. I feel like as both of you are talking about it and the scientists that were in the tour, so listeners, go watch the tour that Aaron did for us. I feel like bringing up these cores brings to you more questions than you brought with the ship. It sounds like you're going to get some answers, but then you're definitely going to get more questions, like homework for scientists.
Yes.
Yeah. It's fun homework because it's like, oh, like what cool, like think of 1,000 projects just from like looking at like a couple set of cores. I mean, it's challenging, and it can be frustrating because like, oh, like what's like, this is completely different than what I thought. But then it's also cool because it's completely different from what I thought.
Exactly. Exactly.
Right. Yeah. And you want to know why. So like, that's like the impetus for it because there's certain machines we don't have here, but we do have at the University of Minnesota that can use to, try to answer.
Right. Okay.
Right. Well,
already thinking forward to stuff you'll do with it.
Oh, yes. Me too.
Yeah. So that's what I think is also cool is because so you guys have done this kind of experiment and whatever, you're gathering all this data, but you're also sharing it with so many other scientists, right? You're going to make some of these cores and the data available to everything else. So this stuff could be studied for 10 years? I don't know. How long do you think you could learn from this?
Decades, yeah. There's still some stuff. This is kind of the continuation of a project that was first done in the 70s.
Yeah. Oh, wow.
Yeah, like it was actually the site that discovered like all the salt deposits. And this is kind of like this is building up complete records. And yeah, that's actually some of the plans for myself and some of the other scientists. Be like, yeah, go back to those records, compare what we have here. And so most likely that'll be our site too. Like people when in the future will look at ours and it'll continue for a very long time.
That's fantastic. I love how science just keeps continuing and keeps asking questions and then answering some, hopefully, right?
Yes. Oh, yeah. So with the physical properties part, Jonathan, how do you know? Like, I'm trying to bring this back all the way back to like my first question of, you said one of the main things you were trying to learn about was climate. And you're pulling rocks and sand and different gray rocks out from a mile down under the ocean, which is already, however deep. How does that help you understand what the climate was like back then?
Well, so that's actually one of the cool things because it's in the ocean. It's kind of, in a sense, kind of segregated from like all these other different things that could potentially like mess with it. Like when you look at a river, there could be different changes in like the way the river's going that could completely obscure your signal. When you're in the ocean, there's not really a lot messing with it other than maybe like some animals kind of drilling down into it in order to like consume or like little like microorganisms to consume other microorganisms. But that's actually part of the climate signal because like those little critters would come up during like, say, like maybe warmer periods or periods with more oxygen in it, where when the climate shifts, like, you know, they might not be there. And that's just like one of the signals that could be the case. It is very deep, but like, remember, like, it's like continuously like being buried, right? So when it was first placed, it was kind of like, you know, it was still in the ocean, but like it was higher up. So it was able to get like that much more recent material.
I guess, could you tell us one of the coolest things you've learned so far about what you guys have done?
You know, I don't have a geology background. I have an engineering background and worked in space and stuff. So it's been a lot of learning for me to be on the ship with all these incredible scientists. So for me, I've been learning from the ground up. Again, no pun. There's all these grounded rock puns. There's so many to make. For me, I think it's been very cool to, well, first of all, just see how excited everyone gets about just the tiniest little things in these rocks. And it's like me learning to get excited about it. And I think the coolest thing was, for me, the connection between space and geology, because there are cycles in Earth's orbit and the direction that Earth is tilting and things like that affect climate cycles on the Earth. And someone called me up when there was a core, you could visually see dark light, dark light, dark light. We were talking about it. I'm like, that is the movement and changes in Earth's position around the sun and everything reflected in that rock right in front of me. And for me, that was like just a cool connection between my two worlds right there.
That's fantastic. I love that. I don't think kids, or maybe even anybody, adults too, think about that and how that's reflected in our planet, especially down in the ocean. Very cool.
Yeah. Anything else from you that you were like was just super cool that you love to see?
So one is actually, seeing the core, which is like, so especially when you're a geologist, when you're hiking out and you're looking for these records out in the field, like out in like Utah or something, like sometimes it can be like impossible to go out and grab it. You know, you have to hike and get the samples. But here you're actually getting like close to, you know, a kilometer of fresh in place sediment right from the ocean. And you can see when it's pulled up, it's got like, you know, I'm not a fossil guy, like, or in the sense, I'm not a specialist in it, but you can see all the fossils in it and stuff. It's weird. Some people are getting sick of them, but I'll never get sick of the pyrite. That's fool's gold.
Yes.
You know, like I see every single core and it gets bigger and bigger, and it's so cool. I love it. You can see the cubes that it forms, and it's amazing. And it's also amazing. It's made out of iron, which is important for my magnetic stuff. And I guess the final thing is just interacting with all the different scientists. Like, I've never really worked with geochemists before. And now, like, I have a question of like, I wonder if this green layer is slightly different from this darker layer. And I just ask them, hey, do you guys have free time to look at it? They're like, sure. And I just sample, go down. 2 days later, they give me a result. And it's awesome.
Cool. that is cool. Yes, definitely.
You know, it's a great.
Just slightly off. What is it like doing all of this on a boat out in the ocean?
Honestly, pretty cool, pretty fun. I do miss my wife, who's back in Texas right now. But it is nice to be like, just, instead of having to wake up and having to pay bills and drive to work, I can just wake up, quickly go to the gym, go do my science, and really cool science at that, and like present my results right away to some of like the bigger people in the field, with Rachel and Manu.
Chiefs.
The co-chiefs, and not have to worry about some adult stuff, adult life stuff, like paying bills and everything.
Our life science while we're on the ship, and we're around a bunch of other people who also are nerding out over this stuff too, which is great.
Yes.
Yes. So after you get off the ship, what's next for you? Are you going to be focusing on spending the next couple of years studying what you did, or are you looking forward to your next kind of research trip?
Yes and yes.
Okay.
When I get back, I have some different projects already in the works that I'll be picking up when I get back. So first, go pick up my wife in Texas when I go back to Minnesota. And then when August comes around, whatever the sampling party was, then getting those samples and getting to work right away. And then hopefully, I would absolutely love a chance to continue working this stuff for years. Yeah. If somebody told me like, you'll do research, but like your entire working life will be just this stuff, I'd be happy. Like that's like winning the lottery for me.
That's good. That sounds fun.
Nice. So along the same lines, Aaron, we have already talked to you about communicating about science, communicating about space and the International Space Station. What's it like for you to be science communicating about a completely different science?
I love being able to just constantly be learning about it. That's my favorite thing about science communication, is being around the experts being able to be immersed in it and learn all of that stuff and then be able to help share it. So super cool. I love, just in the same way that Jonathan's focusing on science every day, I'm focusing on science communication every day. So it's really cool to be able to just go up to the labs, grab all these amazing scientists, record videos with them, share it. We're trying to potentially get a picture taken from space of our ship while we're out here. Fingers crossed. It's been very cloudy recently.
Good luck.
So we'll see if we can make it happen. Just trying to bring all my worlds together. But no, I love it. And it's just such a unique experience. I'd say I can't go to space to be able to communicate science, but I can come out on this ship and be here with all these people and share it. So it's been really rewarding. Maybe I'll go to space one day. We'll see. But right now, just
when Erin said that, like she was just like, oh yeah, I called my friends at NASA. We might be able to do a satellite flyover for like a photo shoot. And I was like, that is the coolest thing anyone has ever said ever.
Yes. Fingers crossed.
Hopefully, yeah.
That would be fantastic. This has been such an amazing conversation. We've learned so much, but now we are at the point in the show where we ask our guests to give our listeners a challenge. What challenge do you have for our listeners?
Yes. Well, I'm going to give you two things.
Okay.
One is, this is an easy one, just to give you a visual of what it's like to pull a core out of the ocean. So if you stick a straw into a cake or a cupcake, you can get an idea of what a core is like, especially if the cake has layers in it. You stick it in it and then put your finger over the top of it and pull it out. You should get your own little cake core at home. And you can take a look at all the different little layers of frosting and cake. And that's kind of what we're looking at when we're looking at in the ocean. And then the other is just to go outside and pick up some rocks and take a look at them. Maybe you can try to do some Googling and figure out what type of rocks they might be. But just take a minute to appreciate all of those rocks in your world.
Yeah, the best geologists have seen the most geology. So yeah, go out, look for and it could be your local rocks. It can just be maybe even like tabletop counters, or always have some cool like igneous rocks in there, minerals and stuff. So yeah, no, it's everywhere. Get out there and look at it. Yeah, exactly. Maybe find some fossils.
Jonathan, I love what you just said. The best geologists see the most geology. That's perfect.
Yeah. Yes, that's fantastic. Oh my gosh. This has been so amazing. Thank you so much, both of you, for being on Solve It for Kids.
Wow, what a super episode. My goodness, all of this is happening right now. Erin's aboard the ship. John decided to give us some time. What a cool tour that we were able to see around the ship. They are doing such amazing science out there right now. And even if you're not a geology nerd, how can you not like these huge core samples they're taking so far down from the bottom of the ocean? And what about this challenge? One of our tastiest yet, even though they gave us 2 challenges, to take core samples from either a cake or cupcakes. So I can hear our listeners now. I know I'm going to do it. Hey, Mom, we need to bake some cupcakes because I need to do core science.
Yes, I'm down with that as well. I think that would be tons of fun. And also so much fun to see the different layers too. So you can also have fun baking the cupcakes. So don't just make complete chocolate ones. Put some rainbow colors in there so you can see different layers. But also, of course, her second challenge was to go outside and pick up rocks. We love rocks, right? Go take a look at them, try and figure out what they're made of, maybe compare and contrast. There's so many cool things you can do with rocks. And if you do the core sample and you want to share that with us, you can always tag us on our social media. We are at KidSolve at Facebook, X, and Instagram. And don't forget to check out our website, solveitforkids.com, where you'll find more information and the cool video that Erin made for us at the beginning. Don't forget to watch that so you can see what the ship looks like. That will be on our website. And finally, there will be books so you can learn more about the ocean, about rocks, about all these different kinds of things. We want you to go out and explore your own curiosity.
So here's the deal. After you make your core sample cupcakes, take one of the cupcakes, wander outside, pick up those rocks, and get Jennifer's book, Rocks, Fossils, and Shells, to help you identify what they are. Until next time, you'll hear Jen and Jeff on Solve It for Kids.